In this video, we're going to be evaluating an exponential function that models a real-world situation. Okay, so for the first problem, it says we have a rate of inflation that is 2.6% per year, and the future price, P of t, of a certain item can be modeled by the following exponential function, where t is the number of years from today. Okay, so the problem asked, find the price of the item 4 years from today and 8 years from today. Okay, so quickly let's explain where this 2.6 goes in this, because they already wrote the function for us, but here is the 2.6 right here. So if you didn't have a 2.6% increase each year, this would just be 1. Okay, that number would just be 1, which means that the price would always stay at this $3,000. Okay, so if you convert 2.6 into 2.6% into a decimal, you would move the decimal twice, so it would be 0.026, and that's where the 0.026 on this comes from. Okay, but on this they already wrote the functions for us, so we don't have to do much work on that. This is the initial price. Okay, so 3,000. So when it says find the price of the item 4 years from today and 8 years from today, all we're going to do is evaluate this function at 4 and evaluate the function at 8. So the first thing I will evaluate is P of 4. Okay, and that is going to be equal to 3,000 times 1.026. And then the exponent is going to be the 4. Okay, we'll figure that one out in a second. I'm going to go to my calculator and do it. For the second one, it would just be P of 8. So it would be 3,000 times 1.026 to the 8th. Okay, so I'm going to show you how to do these in a TI-84. Okay, so here's my calculator. So I am going to go to y equals, and I'm going to put in the function. Okay, and for the variable, I'm not going to use a t, I'm going to use x. So let me type in this function right here, 3,000 times 1.026, close parentheses, and raise it to the power of x, because that's the variable that this calculator uses. Okay, so the reason I did that is because now we can go to our table by hitting second graph, and it gives us all the values that we want. We just have to go to it. Okay, so we were asked to find the value at 4. So this is the value at 4 right here, 3,324. Keep in mind it does say round to the nearest dollar as necessary. Okay, so that would be 3,324. It would not round up. So $3,324. Okay, that would be the cost of the item after 4 years if it was increasing at 2.6% each year. We can also go down here to 8. Okay, so this says 3,683.8. So that one will round up to 3,684. 3,684. Okay, that's how you do it in the graph, which is my preference. I'll also show you how to go find the values just by typing it in out here to your regular part of your calculator. So I would type 3,000 parentheses 1.026 close parentheses, and then I'd raise to the 4th. Okay, so notice it gives me the same answer, right? And if you wanted to raise it to the 8th, by the way, that little trick that I just did, it was second enter. It brings up the last thing you typed, so you can go back and edit it, and I can change it to an 8th, and there's my other answer. Okay, so 2 different ways of getting that. All right, let's look at this other problem really quick. Okay, so a radioactive substance, cesium-137, has a half-life of 30 years. The amount AFT in grams of a sample of cesium-137 remaining after t years is given by the following exponential function, this one. Okay, so round the amount of the sample, or find the amount of the sample remaining after 40 years and 100 years. Okay, so just like the last one, it was the first one, I just evaluate the function at 40, which is going to be 458 times 1/2, and then the t is 40, so 40 over 30, and that's actually 4 over 3. If you don't want to write that, it would reduce. We'll find that in a minute, and then let's also do the a of 100 equals 458 times 1/2, and the t now is 100 divided by 30. Okay, so let's go to the calculator again. I'm going to go to the y equals, let's delete what we have in there and type in our new one, 458, parentheses, 1 over 2, raised to the power of x over 30. Okay, so that is the function that we have. Now I can go to my graph or my table, but notice I'm going to have to do a lot of scrolling down here to get to the one I want, which is just fine. If you just want to hold down the button, you get there pretty quickly. You can also do this, hit second table set, and tell the first one to ask. Change this one to ask. And now when you go back to your table by hitting second graph, you have no values. You can just type in what's the answer at 40 or what's the answer at 100. Okay, and it gives you those two answers. Okay, so for the first one, it looks like it says I need to round to the nearest gram, so I'll round that one up to 182. 182. And then the other one was 45.4, so I'm not going to round that one up. It'll be 45. And that's it.